Hi, Luigi's Pizza? I'd like 3 pepperoni pizzas and make it fast. Hi, do you have my pizza?
Well, I would, but there was a problem. I drove so fast to get to your house that the pizza fell off the top of my roof. So I don't have it anymore.
What?
The thing is, I can make it up to you. I can come into your house and help you make pizza, and we can learn some cool chemistry while we do it.
I don't know about that.
It'll be great. Good thing that you have ready-made dough in your fridge.
What are you doing?
I'm making pizza.
Can we help?
I guess. Now let's learn a cool chemistry fact. What makes this dough rise the way it does? You see, you put something in here called yeast, which is a microorganism in the fungi kingdom and the Saccharomyces family, which means sugar fungus in Greek. This yeast allows for a type of fermentation called biological leavening. This biological leavening is where the yeast reproduces and then consumes fermentable sugars within the dough to produce carbon dioxide. This carbon dioxide then forms little gas pockets within the dough, thus pushing the dough out. This is important for when making dough because it allows the pizza crust to taste like bread as opposed to a cracker or something like matzah. Now, let's cook the pizza. Good work, guys. I'm so hungry though. I'm gonna have some of this pepperoni.
Wait! Eating raw pepperoni is not going to make you feel good, but we'll talk about that later.
Now that we're done making our pizza, it's time to cook it. But what should we cook it on? There's so many choices.
I think that we should pick more than one cooking surface. That way we might be able to find out some cool chemistry.
Okay.
Hey.
Oops.
It's hard work. Now that we're done with cooking the pizzas, let's take a look at the effects that each cooking surface had on the cooking consistency of the pizzas. Then we can explore the cool chemistry behind that. The only problem is, I don't actually know the chemistry.
Well, I know. To cook our pizza, we had to transfer heat energy to the pizza. The heat was transferred 3 different ways, through conduction, convection, and radiation. When we put our pizzas in the oven, heat was transferred through conduction from the direct metal that was touching it and cooking it. It was transferred through convection from the air currents in the oven that surrounded the pizza while it was cooking. And it was transferred through radiation by the heat that was emanating from the walls of the oven. Specific heat of a substance is the amount of heat per unit of mass that is needed to raise the temperature of the substance 1 degree Celsius. The specific heat of aluminum, which we use to heat this pizza, is about 0.214 calories over grams degrees Celsius. The specific heat of cast iron, which we use for this pizza, is about 0.11 calories over grams degrees Celsius. But because cast iron is so dense, it takes longer and more energy to heat up this much cast iron. Cast iron also retains heat for a longer amount of time. The thermal conductivity of cast iron is poor, meaning that the heat energy does not distribute itself well around the entire pan. If you look here, we can see that the center of this pizza is much less cooked than the edges of the pizza because of the poor thermal conductivity of the pizza. When we cooked the pizza on the rack with no metal beneath it except for the rack, the heat did not distribute itself very well simply because the rack didn't cover very much of the pizza.
Well, now that we're done cooking the pizzas, we have to let them cool. But I'm just so hungry. Why didn't you let me eat that piece of pepperoni earlier?
Well, in order to understand why you couldn't have had raw pepperoni, we have to look at the chemistry behind it. When we cooked the pepperoni, the proteins inside of it changed, and this is called protein denaturation. A protein that hasn't been denatured is a natural protein, and it's composed of a string of amino acids that are in a specific order and decide the function of the protein. These strings fold on each other and form weak hydrogen bonds between each other into a complex three-dimensional secondary and tertiary structures. So when we added heat to the protein-rich foods like we did when we put them in the oven, it destroys the secondary and tertiary structures, and the amino acid string becomes unraveled. So therefore, the whole protein is biologically inactive, and it's easier for your body's enzyme to digest it. Denatured proteins form amide bonds between their amino acids, and this means that the proteins lose the capacity to hold a lot of water. And so when you denature a protein using heat, it causes the food to release moisture, which is what you see on top of the pepperoni. So had you had the raw pepperoni, your body's enzymes would have a hard time breaking down the proteins because they were still in their natural form and they hadn't been denatured. The pizza's all cool out.
Thank you.
Thanks. Looks so good.
Oh, I'm so hungry.
Excuse me. I'm so hungry.
Why is the pizza guy eating with us?
So, let's talk about some cool chemistry. Why do you guys think that the spots on this pepperoni are brown?
Oh, I know. The reason why it turns brown is because of this reaction called the Maillard reaction. And this occurs when a food contains carbs in the form of sugar and amino acids in the form of proteins. When a food contains carbohydrates in the form of sugars and amino acids in the form of proteins, the Maillard reaction can occur. It's also the catalyst for change, and mostly by the addition of heat. In fact, the Maillard reaction can't happen without an additional heat source. So when the pizza was put into the hot oven, complex chemical reactions took place on the surface of the pepperoni. The carbon molecules in the sugars combined with the amino acids, and the end result of this chemical recombination was the Maillard reaction. This is also responsible for the flavor change in the pepperoni, which is why it has a more savory flavor after it's been cooked.
Well, that's cool.
I'm still hungry.
I'll go get us some more. Wait, where's all the pizza?
Alright, well, it's been great, so I'll see you guys.